Alright, welcome to the lesson on multiplying polynomials. You actually know how to multiply some polynomials. For example, you know how to multiply two monomials, two terms. So 7x, remember that's a monomial. And let's say I want to multiply that by 5x squared. You should know how to do that from grade 9. All you do is multiply the coefficients, so 7 times 5, 35, and then use exponent laws to multiply the variables. So x, remember it's x to the 1 if you don't remember what the exponent there is, times x squared, so x. So you add the exponents, 1 plus 2, x cubed. So notice when you multiply a monomial times a monomial, you get a monomial. Another example, 3xy, so here we've got more than one variable, times minus 2x squared. So again, you multiply coefficients, so 3 times minus 2 is minus 6, x times x squared, x cubed, and y, and there's no y over here, so we just have the 1y. So again, product of two monomials is another monomial. That's just from grade 9, shouldn't be that different. So this is multiplying monomials. You also know how to do a monomial. So let's just start with a single number, 2, or we said a number by itself can be a monomial, times now a binomial, so 7x plus 1. So here we have a monomial, just write mono, one term, and then a binomial. So we know how to do that if you remember the distributive property. So the 2 gets multiplied by everything in the bracket. So 2 times 7x is 14x, and 2 times 1 is 2. So a monomial times a binomial ends up being another binomial. Another example, let's make the monomial a little bit bigger. So 3x squared, and then we'll multiply it by, let's say, 5x cubed minus 2x. Actually, you could even, it doesn't have to be binomial. You should know even how to do like a trinomial or any amount of terms in the bracket. When you distribute, just multiply the monomial in front by every term in the bracket. So 3x squared times 5x cubed, 3 times 3, 15, and then use exponent laws to multiply the variables, so x squared times x cubed, x to the 5, 3 times minus 2, minus 6, x squared times x cubed, 3x squared times 1 is just 3x squared. So when you multiply the monomial times a trinomial, you get a new trinomial. And then you should be able to extend this to multiplying a monomial times any length of polynomial, right? If I threw in 10-term polynomial here, you would just multiply that monomial times all 10 terms. So it just gets to be a longer equation, but it's not really anything new. But now we're going to do something a little different, and that would be multiplying binomials. So before, you could do a monomial times anything, but what if you have two binomials? So something like two simple ones. So 2x plus 1, so two terms, 2x is a term and 1 is a term. Let's do times 3x minus 4. So another two-term polynomial. So here we have two binomials. Well, to do this, it's actually very similar to what we did above. So remember with the monomial, you used, I don't know if I mentioned the property, but remember we call that the distributive property. So we multiplied the monomial times every term in the binomial. Here, we're just going to take every term in this binomial and multiply it by every term in this binomial. So first I'll do the 2x. So I'm going to take the 2x and multiply it by every term in the second binomial. Then I will take the 1 and multiply it by every term in the binomial. So 2x times 3x, 6x squared. 2x times minus 4 is minus 8x. So I've multiplied the 2x by both terms. Now I need to multiply the 1 by both terms. So 1 times 3x plus 3x. 1 times negative 4, negative 4. Now I've multiplied both the terms here by both the terms here, and now I have 4 terms, but notice in this case 2 of the terms are like, so I always need to simplify the final. So minus 8x plus 3x, just add coefficients, so minus 5x minus 4. So I've created a trinomial. So I multiplied this binomial, got a trinomial. We can do another one. 3x minus, let's put different variables in here. Minus 5y times 2x squared plus, I don't know, how about just y? So again, take the first term and just multiply it by both the terms in the second bracket, and then take the second term and multiply it by both the terms. So first, 3x times 2x squared, 6x cubed. 3x times plus y would be 3xy. So that's the 3x times both terms. Now, minus 5y times 2x squared would be minus 10x squared y. Now, you might have wrote yx squared, but I have this pattern of writing the x and y first. So that's what I'll do. Minus 5y times y, so minus 5y squared. And now notice there's no like terms, so here I can't go any further, so I have a 4-term polynomial. So in this case I had the trinomial because I was able to simplify, but in this case I was not. And that's multiplying binomials, really. That's all you need to do. I'll do a couple more. Actually, let's make it a little harder. Let's throw in a monomial, so 3, times a binomial, times another binomial. So notice there's 3 polynomials being multiplied here. A monomial and 2 binomials. Well here, you've got options. You're multiplying 3 things. Usually what you do is you multiply the first 2, and then multiply the result of that by the third one. So I'm going to look at these 2 first. So I'll multiply 3 times x plus 1. Well, it's just distributive property. So that would be 3x plus 3. Put that in a bracket, and then I'm going to multiply that by x minus 5. So now I just have to use the distributive property I did over there, where I distribute both terms into the second bracket. So 3x times x, 3x times minus 5, 3 times x, 3 times minus 5. So 3x times x, 3x squared. 3x times minus 5, minus 15x. 3 times x, plus 3x. 3 times minus 5, minus 15, and now notice like terms again, so I'll just collect those. So it would be minus 12x minus 15, and that's a simplified expression, so a trinomial. So I can multiply 3 terms. Okay, so I think really using what we've just done, you can probably multiply any amount of polynomials, any size, if you just sort of extend.